Hello, sixth graders. Welcome to sixth grade math dividing decimals lesson. Pause while you write the lesson title in your interactive student notebook. Pause again while you write today's lesson objective in your notebook. Today's objective is I can divide decimals by completing practice problems with 100% accuracy in multiple attempts. The Arizona State Standard we'll be addressing today is fluently add, subtract, multiply, and divide multi-digit numbers, including multi-digit decimals, using the standard algorithm for each operation, and assess the reasonableness of the result. Let's take a look at the key idea. You do need to write it in your math notebook. Dividing decimals by whole numbers. Place the decimal point in the quotient above the decimal point in the dividend. Then divide as you would with whole numbers. Continue until there is no remainder. Be sure to write the entire key idea with the example in your notebook. Let's take a look at example 1, dividing decimals by whole numbers. Letter A, 7.6 divided by 4. So we estimate, we use rounding, and our estimate turns out to be 2. And then our directions here say place the decimal point in the quotient above the decimal point in the dividend. So I am going to write a note here, which I want you to add to your notes, that says do first. This will save you so much hassle in the end, because if you try to put your decimal point there after you've got your numbers and things aren't lined up correctly, your decimal point might end up in the wrong spot. So then you just follow the way you were taught to divide using long division. So remember, you divide first, and then you multiply, and then you subtract, and then you check to be sure that your remainder is less than your divisor, and then you bring down the next number. So you say, does 4 go into 7? Yes, it does. It goes in once. So that's your division, and then you multiply. 4 times 1 is 4, and then you subtract your 4 from your 7, and you get 3. You check to be sure that your remainder is less than your divisor. 3 is less than 4, so you continue on and you bring down the 6 to make that a 36. And then 4 goes into 4 goes into 36 9 times. 4 times 9 is 36. Your remainder is 0, and you are done. And then you check to be sure that your answer is reasonable. 1.9 is close to 2, so it is. The next one, we're not going to do an estimate because our numbers are kind of funky here. So we've got 4.38 divided by 12, so you've got a small number being divided by something that's larger than that, so it's harder to estimate. So instead, we're going to check at the end using multiplication, so we'll talk about that. So again, your first number goes inside the bracket, and your second number goes outside the bracket, just like with whole numbers. Nothing has changed. And you put your decimal point up on top of the bracket, and you continue on using your algorithm for long division. At the end, you need to be sure you add this 0 because you have a 6 here. You have 78 minus 72 equals 6. And you add a 0 there because you can't put remainder 6 in a decimal problem. So you have to add a 0, and then you say, well, 12 goes into 65 times, and that gives me a remainder of 0. So remember to do this step, to keep going either until your decimal repeats or until it resolves itself and your remainder is 0. And then we check by multiplying our quotient by our divisor. And the quotient times the divisor should equal the dividend. If it does, then you got the right answer. And it does, so we did. Here's another key idea, dividing decimals by decimals. We multiply the divisor and the dividend by a power of 10 to make the divisor a whole number. Then place the decimal point in the quotient and divide as you would with whole numbers. Continue until there is no remainder. So, what confuses kids is we want to say, okay, we want to move our decimal point over until it gets to the edge of the bracket there. Sometimes we say kick the ball to the wall, and that's fine, but if you move the decimal point on the outside of the bracket, you have to move the decimal point on the inside of the bracket in order to keep things balanced. So we're actually multiplying each number by 10. You don't need to worry about what operation you're doing or what number you're multiplying it by. What you need to worry about is if you move the decimal point one place to the right in one number, you have to do the same thing to the other number. And then you're going to place the decimal point above the decimal point in the dividend, and you're going to do the same thing you did in the last examples. So write this in your notebook because it's a key idea and it has the pencil. And then join me on the next example. Example 2, dividing decimals. So let's look at our study tip. Multiplying the divisor and the dividend by a power of 10 does not change the quotient. And it gives you some examples here. So when you get to your quotient or your answer, don't go back and try and undo what you did. You just need to stick with your quotient and you're done. So we have 18.2 divided by 1.4, and I'm going to go ahead and estimate that because 18.2 you can round to 18, and 1.4 you can round to 1. 18 divided by 1 is 18. So that's one way to do your checking. You can also go back and multiply as they did at the end. So you're going to multiply each number by 10, which is the same as moving the decimal point one place to the right, and then you do your division. So 14 doesn't go into 1, but it goes into 18 one time. So you put the 1 over the 8, not over this 1. Sometimes we like to put a 0 there so that it doesn't sneak over into the wrong spot. 14 times 1 is 14. You subtract, there's a 4, you bring down the 2. 14 goes into 42 exactly 3 times, so you end up with a remainder of 0. So you can check your work either by multiplying or by checking your estimate. Find 0.273 divided by 0.39. Here you should probably check by multiplying. So we're going to move our decimal point over 2 to the right and 2 to the right. So you end up with 27.3 divided by 39. And you go through your same steps of multiplication. You end up with 0.7 for your answer, and you check that with multiplication. Let's check out our study tip here. It says, remember to check your answer by multiplying the quotient by the divisor. We've been doing that. And example 3 says, inserting zeros in the dividend and the quotient. So we're going to divide 2.45 divided by 0.007. That's 7 1/1000ths. So 2.45 goes inside the bracket, and 0.007 goes outside the bracket. So it takes us 3 jumps to get over to that wall. So we have to move this decimal point 3 places and put our decimal point on top. So what we end up with is 2,450, but we had to add a zero there on the end because we didn't have enough places in the problem to move our decimal point. So that's what this box is about. We multiplied each number by 1,000, and we had to insert a zero in the dividend in order to put our decimal point. And then we divide as if they're whole numbers because now they are. And when we do that, we have 7 going into 24 3 times. So we be sure 3 ends up above the 4. 7 times 3 is 21. That gives us a remainder of 3. We bring down the 5. 7 goes into 35 5 times. 7 times 5 is 35. That gives us a remainder of 0. But 7 times 35 is not 2,450. We still have a number to bring down. So we have to bring down that 0, and then we have to ask ourselves, how many times does 7 go into 0? Well, it goes into 0 0 times. So you still need to insert that 0 into the quotient. You need to complete the problem. Don't let it hang there. And then if you check your work, you will know that you have the right answer. If you check your work and you have 35 times 7, you will only end up with you will end up with the wrong answer. You will end up with something that is not 2,450. So be sure you're checking your work. Here is example 4, our real life application. How many times more cellular phone subscribers were there in 2011 than in 1991? Round to the nearest whole number. So when you see this, how many times more, it means you're doing the opposite of multiplication, which is division. You should probably write that down. So you look at the graph, and it says from the graph there were 331.59 million subscribers in 2011 and 7.6 million in 1991. So you have to take these in order. 2011 comes first in the problem. So you want to take that big number and you want to divide it by the small number. So not because it's big, but because it comes first. It asked you how many times more were in 2011 than in 1991. So you take the 2011 number, which is 331.59, and you divide that by 7.6. And remember, these are in millions, but you don't have to put on the millions. So you estimate first, and you come up with 40, and then you do your division. So you swoop the decimal point over one place, and you move it up to the top of your bracket. And 76 goes into 331 4 times. So remember, it didn't go into the first 3, it didn't go into the second 3, so it didn't go into 3, it didn't go into 33. And then you continue on down the problem. So there were about 44 times more subscribers in 2011 than in 1991. So since it says about how many, and they wanted you to round to the nearest whole number, be sure you're rounding the answer, not the problems, not the numbers in the problem. So round your quotient, not your dividend and your divisor. And it asks, is it reasonable? Yes, it is. Remember, you need to complete your notes in your interactive student notebook and also do your Google form questions. Review the lesson if you need to. Remember to do your Big Ideas math assignment in your Math Spiral notebook and submit that when it is 100% correct, not before. And remember to track your progress on your playlist.